just take a further look at practicing drawing some graphs here. So I'll just go through the key steps and then an example. So yeah, the key steps, again, try both of these parts on your own first. So pause the video and then go through this. So first of all, the key steps are use the function to determine, so just the general equation of the function, things like intercepts, asymptotes, and holes, and general behavior. So if you have like a quadratic, quartic, cubic, like what are its starting and end quadrant. Use the first derivative essentially to get the critical points, and also then intervals of increase and decrease. And then we can use the second derivative to basically figure out what are the inflection points or points of inflection. And also intervals of concavity. The last thing we want to do is also, I mentioned critical points, determine if max or min. And we can basically do that, use the first or the second derivative test. Doesn't matter which one you use. And with those pieces of information, we can then graph our function. So let's try this out with the function 2x squared minus 5x minus 3 all over x squared minus x minus 6. Okay, so starting things off, let us simplify this function, factor it. So to factor this function, what we're going to get is 2x plus 1 is my guess, x minus 3. Double check that. We get negative 6x, and then plus 1 is negative 5x. All over x minus 3, x plus 2. So the minus 3's cancel out. So we have a whole at x equal to 3. Let's figure out the value of the function at that particular x equal to 3 value. And it's a whole, so it's not actually going to appear on the graph, but we'll draw it as a whole there. So f of 3 is equal to, well, 2 times 3 plus 1, all over 3 plus 2, which is just 6 plus 1 is 7 over 5. So whole at 7/5. No, sorry, 7/5. 3 and 7/5. So there we go, we've got the whole. Let's figure out some other things. So let's figure out the x-intercepts. So in this case, we have just one x-intercept from the numerator, negative 1/2. The y-intercept, set x equal to 0, and you just get 1 over 2. Let's also determine our horizontal and vertical asymptotes. So the horizontal asymptote, well, let's look at the degrees. The degrees are identical. So we just have to, for the numerator and the denominator. So we look at those lead coefficients, and it's 2 over 1. So 2. And for the vertical asymptote, well, that's just in the denominator. We have an x plus 2. So that's going to mean the vertical asymptote is negative 2. Okay. That's looking good. And let's check where it crosses the horizontal asymptote. Well, let's see if it does. So set your equation equal to 2. So 2x plus 1 equal to x plus 2. Move that over. 2x plus 2 equals 2x plus 1. Just going to specify the asymptote there. So then, well, 2x cancels 2x. You're left with 2 equal to 1. Not possible. So it does not cross the horizontal asymptote. Okay, so we've got all kind of the basic information from just the original function. Now let's start making use of the derivative. So we'll have to do a little bit of quotient rule here. So the original function is 2x plus 1 over x plus 2. So we're going to have 2 times x plus 2 minus x plus 2 is just going to give us derivative of 1 times 2x plus 1. All of that over, well, just x plus 2 squared. And simplifying things out, you get 2x plus 4 minus 2x minus 1 over x plus 2 squared. And that's just equal to 3 over x plus 2 squared. All right. And so that's our derivative. So f prime of x, when does that equal 0? Well, never. But it is undefined at x equal to -2. So the vertical asymptote. So let's check that on the number line just to get our intervals of increase and decrease. So -2 is there. Let's test out something like -4 and 0. And so let's check this out. So again, I'm just plugging this into the function. It's going to be positive in the numerator over something squared, which is positive. So it's going to be positive. So the derivative is positive. And same thing here. If you plug in something, it doesn't matter what you plug in. You have the positive number 3 divided by something squared, which is positive. So you're always going to get something positive. So we're basically always increasing except at that vertical asymptote. So that's helpful to know. And then the last part is, let's figure out some information from the second derivative. So the second derivative, another quotient rule, so it's going to be, well, actually we can simplify this a little bit so we don't have to use quotient rule. I'm just going to call this 3x plus 2 to the -2. So the second derivative is just -6 x plus 2 to the -3. If you chain rule that, well, x plus 2 just is derivative of 1. So it doesn't actually make a difference. And -6 over x plus 2 cubed. Okay, so there we go. And again, let's see when it's 0. For inflection points, well, never, because the numerator can't be 0. But it's undefined at x equal to -2, where that asymptote is. Okay, so again, let's do another quick check of a number line. -2, test out some random numbers, bigger and smaller, and let's see what happens with our derivative this time. So we're going to have a negative in the numerator now over, well, we're going to have -4 plus 2. So that's going to be a negative cubed, which will be a negative. So this is going to be a positive number for that. That'll be the second derivative. So to the left of -2 is positive, and to the right of -2, if you plug in 0, you're going to have negative divided by, well, 0 plus 2 cubed is going to be 2 cubed, which is positive, which is a negative value. So this time we actually have different signs going on. So it's concave up. And when it's less than -2, and concave down when it's greater than -2. All right, so there we have it. We've got a lot of information, so let's draw the graph. I'm just going to draw it freehand here. You'll have to do so as well too. And then let's include all this information. So we're going to start with the asymptotes and the intercept. So the asymptotes at -2 and 2. So x equal to -2 and y equal to 2. Again, using a ruler is always recommended. Okay, and then the intercepts, x equals to -1/2 and y equals to 1/2. So somewhere like that. And then, well, that's really it. It's not crossing the asymptote, so we don't have a point there. We don't have any critical or inflection points. We just have to pay attention to the concavity and the increasing, decreasing interval. So it's increasing all the way up to -2. We have that to start off with, as well as being concave up, which will mean it looks something like this. On the other side of -2, it's also increasing, and it's concave down. So what we'll see is if we're by the asymptote, it's got to be coming from the bottom of the asymptote and upwards. Concave down is giving it this U upside down shape, where it's approaching the horizontal asymptote. And there we have it. That is how we use all of our information to draw a graph.